This is segment 4 of the Module 6 lecture. In this case, as I mentioned in the previous recording, that we're gonna go over how to get this probability. So there are 4 cases. So let's talk about probabilities to the left. Well, actually, we already talked about it, but let's review it. All right. So the first case is when they ask you, well, the problem asks you to find the probability to the left of a z value. So in other words, they're asking for a probability that the random variable z is less than some c sub 0 value. In this particular example, they're asking us to find the probability that the random variable z is less than 1.23. My suggestion as you get started, as you learn this, is to sketch the normal distribution and shade the area under the curve to the left of the value. And remember, the z-scores are multiples of standard deviations. So this z-score value is 1.23 standard deviations above the mean. Above the mean because the number is positive. So 1.23 is 1.23 standard deviations above the mean. All right, once you have that value, then you go into table 4 and find the corresponding probability. So now, if you look at your table 4, you look for the first part of the number, which is 1.2. And then at the top, you look for 0.03, which is right here. So the probability to the left of 1.23 is 0.8907. My cursor disappeared for a while, but it's right here. All right. So now you see that that's the probability that we found. So the probability of the random variable z is less than 1.23 is 0.8907. All right. So these are the probabilities to the left are obtained directly from table 4. All right. Case 2 is where they ask us to find the probability to the right value of z. To the right of the z value, rather. So in this case, they're asking us to find the probability that the random variable z is larger than some number. So in this particular example, we're looking for the probability that z is larger than 1.23. Again, sketch the normal distribution and shape the area now to the right of the z value of 1.23. So that's what we have right here. This is the probability we're looking for. All right, so what do? In this case, we then find the probability that the random variable is less than 1.23 from table 4. So less than 1.23. So now you see that this is a complement of this. So once you find that probability, well, then you just subtract it from 1 because this probability right here is a complement of this. So if I know this probability and I know the total area under the curve is 1 and I want to find this piece, then I do 1 minus this probability and that will give me the probability for the section that I'm looking for. So the probability that the z value is bigger than 1.23 is 1 minus the probability that z is less than 1.23 or 0.1093. So whenever you are looking for probabilities to the right of the z value, we rely on the complement rule to find the probability to the right by calculating or finding the probability to the left. All right, so that's the second case where they're asking us for probabilities to the right of some value. All right, the third case, which is very common, is when they're asking us to find the probability that the random variable is between 2 values, z1 and z2. And note that z1 is always smaller than z2, right? Because then we're looking at the random variable is larger than z1, but it's smaller than z2, right? In this example, they're asking us to find the probability that the random variable z is between minus 0.75 and 1.3. Again, the first thing to do is sketch the normal distribution, mark the 2 values. So minus 0.75, that means that this is 0.75 standard deviations to the left of the mean because it's negative. And this other one is 1.23 standard deviations to the right of the mean because it is positive. So that's how I'm locating my z values. Now, then we find the probability that z is less than minus 0.75. So the probability here in this part. And then the probability less than 1.23, this probability, all the probability up to here. So now if you see graphically, the probability that z is less than 1.23 includes all the area to the left of this value, all of this. And then the probability to the left of minus 0.75 includes this part. So that you can see if I subtract this chunk of probability from this overall probability, well, I end up precisely with the piece that I want. So how do we find this probability? Well, we calculate the cumulative probabilities, that is the probability to the left of the upper value and the lower value, and we subtract the lower probability or the smaller probability from the bigger probability. And that's what I'm indicating here. So the probability that the random variable z is in between minus 0.75 and 1.23 is equal to the probability that the random variable is less than 1.23, which is a bigger probability, 0.8907, minus the probability that z is less than 0.75, the smaller probability. So if I subtract these two numbers, I get 0.6641. So again, to find the probability that z is between two values, we're going to simply subtract the two probabilities, the smaller probability from the larger probability. And the larger probability will correspond to the larger z value. And the smaller probability will correspond to the smaller z value. Okay. So this is the third case. We find probabilities that a random variable is between two values. The last, and here's where I find the probability minus 0.75. So here's minus 0.7. And if you go to 0.75, it's 0.2266. And that's what we have right here. All right, very good. So the last case is where they ask us to find the probability that z is to the left of some z1 value or to the right of some z value 2. So, and in this case, so it's the probability outside to z values. And here I notice that this is incorrect, so I need to correct this statement. But here, let's look at the example. This is correct. So we're looking for the probability that z is less than minus 1.23. So this should be z, capital Z, less than z1, or z larger than z2. And in this case, we're looking for z larger than 1.3. Again, always sketch a normal distribution. Now, you know that these z values are multiples of standard deviation, so you think of the empirical rule and you can more or less locate where these values are. It's not important that you mark them exactly. What is important is to realize what areas of probability you're interested in calculating. So the probability that z is less than minus 1.23, well, is this part right here. Right, and the probability that it is bigger than z2, or in this case, the probability that z is bigger than 1.23, then is the probability to the right of the z value. Again, this is backwards, this number right here. It should be bigger than. Correct that. All right, so from table 4, we find the probability that z is less than minus 1.23. So you go here, minus 1.23, minus 1.2, and you find minus 1.23, and you see that that's 0.1093. So right here, 1.093. So now if you find the probability less than 1.23, which is a complement of this probability, is 0.89707. So to find the probability to the right of z of 1.23, is 1 minus the probability to the left, which is 0.1093. And surprise, surprise, they're the same number. Why? Well, because this is z-value 1.23 standard deviations below the mean, and this is 1.23 standard deviations above the mean. And remember, this is a symmetric distribution, so the probability to the left of minus 1.23 is just the probability to the right of 1.23. So really, to answer this question, because we use the same number on the left and on the right, is just find one of the probabilities and multiply it by 2. And as you can see, I went the long way and I found the two probabilities, add them, and I found the probability that the random variable is to the left of minus 1.23 or to the right of 1.23 is 0.1861. And remember, you can go this route, or remember to use the symmetry of the distribution and take advantage of that to answer the question faster. So as I said, all I needed to do is find this probability, and because of the symmetry of the distribution, the same probability is to the left of this value as a probability to the right of the positive z-value. Okay, so this represents the 4 possible questions that you will encounter about obtaining probabilities with standard normal distribution, that is from table 4. Now, just to let you know, I put how to calculate each of these probabilities using Excel. So this is a probability to the left, which are obtained directly. For the probabilities to the right, we use the complement. The probabilities to the values between two values is just the difference between the two probability distributions, the one with the larger value and the one with the smaller value. And in these cases, I'm showing you for calculating directly the probability of an x value, or if you prefer a z value. So I'm giving you both choices in every case. And this is the 4th case. And again, this looks a bit intimidating, but you can see is the probability to the left plus the 1 minus the probability to the right, the complement. And again, I'm not using symmetry because I do not know if x1 is equal to x2 or if z1 is equal to z2. When they are equal, when these two numbers, z1 is equal to z2 and x1 is equal to x2, then I take advantage of the symmetry of the normal distribution and just duplicate or multiply by 2 the probability to the left of one of the values. All right, I'm going to stop here. In the next section, now we're going to apply the normal distribution to solve some specific problems.